Welcome. In this video, we'll explore the world of failover clustering in Windows Server and Azure Local. Failover clustering is a foundational technology for high availability and scalability, ensuring your critical applications and services remain online, even if hardware or software failures occur. We'll break down what a failover cluster is, why it matters, and how it fits into modern IT environments. Whether you're running Windows Server 2016, 2019, 2022, 2025, or Azure Local, this guide will help you understand the essentials and advanced features. Let's get started by defining the core concepts and setting the stage for a deep dive into planning, deployment, management, and troubleshooting. Failover cluster is a group of independent computers known as nodes that work together to increase the availability and scalability of applications and services. These nodes are connected by both physical cables and software. If one node fails, another node automatically takes over its workload, a process called failover. This seamless transition minimizes service disruptions for users. Failover clusters are commonly used for file shares, SQL Server, Hyper-V virtual machines, and more. The clustered roles are proactively monitored, and if they're not working properly, they're restarted or moved to another node. This proactive approach ensures your business-critical services remain available. Failover clustering offers several key benefits for organizations. First, it provides high availability by minimizing downtime during hardware or software failures. Second, it improves scalability, allowing you to add more nodes as your needs grow. Third, it supports cluster shared volumes, CSV, giving all nodes consistent access to shared storage. This means applications like SQL Server and Hyper-V can run smoothly across multiple servers. Finally, failover clustering is designed for both physical and virtual environments, making it versatile for modern data centers and hybrid cloud scenarios. These advantages make failover clustering a must-have for mission-critical workloads. Cluster shared volumes, or CSV, are a core feature of failover clustering. CSV provides a consistent, distributed namespace that allows all nodes in the cluster to access shared storage simultaneously. This is especially important for workloads like Hyper-V and scale-out file server, where multiple nodes need concurrent access to the same data. CSV simplifies storage management and enables quick failover of workloads without remounting volume. CSV volumes can be formatted with NTFS or RAIFS, and they support advanced features like BitLocker encryption and deduplication. By leveraging CSV, organizations can achieve both high availability and efficient storage utilization. Failover clustering is used in a variety of real-world scenarios. For example, it provides highly available file shares for applications like SQL Server and Hyper-V virtual machines. It also supports clustered roles running on physical servers or virtual machines, ensuring continuous access to critical services. Organizations rely on failover clusters for disaster recovery, load balancing, and seamless maintenance operation. Whether you're running a two-node file server or a large-scale cluster set, failover clustering adapts to your needs, supporting both on-premises and hybrid cloud deployments. These practical applications make failover clustering a cornerstone of resilient IT infrastructure. Failover clustering is supported on a wide range of Microsoft platforms, including Windows Server 2016, 2019, 2022, 2025, and Azure Local. It's also available in Azure Stack HCI and integrates seamlessly with hybrid cloud environments. This broad support ensures that organizations can implement high availability regardless of their infrastructure, whether it's on-premises, in the cloud, or a combination of both. Microsoft continues to enhance failover clustering with each new release, adding features like dynamic quorum, cloud witness, and improved management tools. This commitment to compatibility and innovation keeps failover clustering relevant for modern IT needs. Proper planning is essential for a successful failover cluster deployment. Start by defining your availability and scalability requirements. Next, select hardware that meets Microsoft certification standards and ensure all components are compatible with your chosen Windows Server version. Plan your network topology to avoid single points of failure. Use multiple network adapters, redundant switches, and separate networks for management and storage traffic. Consider your storage options such as storage spaces direct, SAN, or SMB3 file shares. Finally, determine your quorum configuration and witness type to maximize cluster resiliency. Careful planning sets the foundation for a robust, reliable cluster. Build a failover cluster. You need matching servers with similar components, certified for your Windows Server version. All hardware must pass the cluster validation tests to ensure compatibility and reliability. For network adapters, dedicate each one to either network communication or ISCSI storage, and avoid single points of failure by using redundant networks and teamed adapters. Storage controllers and HBAs should be identical across all nodes, and storage must be compatible with Windows Server. For Hyper-V clusters, ensure your processors support hardware-assisted virtualization and data execution prevention. Meeting these hardware requirements is crucial for a stable, high-performing cluster. Resilient network design is key to cluster reliability. Use multiple distinct networks to connect your cluster nodes, or employ teamed adapters and redundant switches to eliminate single points of failure. For ISCSI storage, dedicate network adapters exclusively to storage traffic. Ensure all network adapters have identical settings and are compatible with your switches. Use unique subnets for private networks, and configure DNS for name resolution. By following these best practices, you'll ensure that your cluster can withstand network failures and maintain continuous service availability. Failover clusters support a variety of storage options, including storage spaces direct, SAN, and SMB3 file shares. Storage must be certified for your Windows Server version and configured for high availability. Use basic disks formatted with NTFS or RAIFS and avoid dynamic disks. For clusters with a disk witness, you can use either NTFS or RAIFS. Storage should be isolated to each cluster, and multipath I/O or network adapter teaming is recommended for redundancy. Proper storage configuration ensures data integrity and supports seamless failover of workloads. Quorum is a critical concept in failover clustering. It determines the number of failures a cluster can sustain while remaining operational. Each node and witness gets a vote, and more than half the votes must be active for the cluster to run. This prevents split-brain scenarios where multiple parts of the cluster think they're active, risking data corruption. There are several quorum modes: node majority, node and witness majority, and disk witness only. Choosing the right quorum configuration ensures your cluster remains resilient and avoids downtime during failures. There are three main types of quorum witnesses: cloud witness, disk witness, and file share witness. A cloud witness uses Azure Blob Storage for voting, offering low maintenance and high availability. A disk witness is a shared disk accessible by all nodes, storing the cluster configuration database. A file share witness uses an SMB file share and is ideal for multi-site clusters or when shared disks aren't available. Each witness type has its own requirements and best use cases. Selecting the right witness type is essential for maintaining cluster health and preventing split brain. Dynamic quorum and dynamic witness are advanced features that automatically adjust the number of votes required for quorum as nodes go offline or come back online. This flexibility allows the cluster to survive sequential node failures and even run on a single node in certain scenarios. Dynamic witness toggles the witness vote to keep the total number of votes odd, reducing the risk of losing quorum due to witness failure. These features enhance cluster resiliency and simplify management, especially in environments with changing node counts. Cluster sets are a powerful feature for scaling out your infrastructure. A cluster set is a group of multiple failover clusters managed as a single entity. This allows you to increase the number of nodes in your data center, improve resiliency, and manage workloads more efficiently. Cluster sets support live migration of virtual machines across clusters, unified storage namespaces, and Azure-like fault domain. They're ideal for organizations running large-scale, highly available environments that require flexibility and scalability. Fault domain is a set of hardware components that share a single point of failure, such as a rack, chassis, or site. By distributing your cluster nodes across multiple fault domains, you can protect against larger-scale failures like rack outages or site disasters. Windows Server supports defining fault domains at the node, chassis, rack, and site levels. This awareness enables features like storage affinity, improved health service alerts, and enhanced resiliency for storage spaces direct. Proper fault domain configuration is essential for achieving true cloud-like uptime. Let's walk through deploying a two-node file server failover cluster. Start by ensuring both servers meet hardware and software requirements and are running the same Windows Server version. Connect the nodes to shared storage and configure at least two volumes, one for the witness disk and one for shared files. Install the file server role and failover clustering feature on both nodes. Validate the configuration using the Failover Cluster Manager, then create the cluster and assign a unique name. Finally, configure the file server role, add shares, and test failover to ensure seamless service continuity. Validation is a critical step before putting your cluster into production. Use the Failover Cluster Manager's validation wizard to run a series of tests on servers, networks, and storage. These tests check for hardware compatibility, network redundancy, and storage reliability. Review the validation report for any warnings or errors, and address issues before proceeding. Only clusters that pass all validation tests are supported by Microsoft. Proper validation helps prevent future problems and ensures your cluster is ready for high availability. Once validation is complete, use the Failover Cluster Manager to create your cluster. Enter the names of the nodes, assign a unique cluster name, and configure the cluster's IP address. If you're using static IPs, specify them during setup. After creation, review the summary and ensure all resources are online. The cluster is now ready for role configuration and workload deployment. Remember, a well-named and properly configured cluster simplifies management and troubleshooting down the road. Provide highly available file shares, configure the file server role in your cluster. Use the Failover Cluster Manager to add the role, select the type, general use or scale out, and assign a client access point. Choose the storage volume for your shares and set permissions as needed. You can enable features like access-based enumeration and offline caching. Once configured, your file shares will be available from any node, and failover will be seamless for users. This setup is ideal for storing application data, user files, and more. Cluster shared volumes, CSV, enable multiple nodes to access the same storage simultaneously. This is crucial for workloads like Hyper-V and Scale-Out File Server. CSV volumes appear as mount points under the /cluster storage folder and can be renamed for clarity. CSV supports direct I/O for performance, and in case of connectivity issues, it redirects I/O through the coordinator node. CSV also supports advanced features like BitLocker encryption and deduplication, making it a versatile and secure storage solution for your cluster. Scale-Out File Server is designed for application data, providing active file shares that are continuously available. All nodes in the cluster can serve SMB client requests and bandwidth scales with the number of nodes. This setup is ideal for Hyper-V virtual machines, SQL Server databases, and other high-performance workloads. Scale-out file server simplifies management, supports automatic client rebalancing, and leverages SMB3 features like transparent failover and multi-channel. It's the recommended choice for scalable, resilient file storage. Clusterware updating automates the process of applying software updates to clustered servers while maintaining availability. CAU puts each node into maintenance mode, moves workloads, installs updates, restarts if needed, and brings the node back online. This process repeats for each node, ensuring minimal service interruption. CAU supports both self-updating and remote updating modes, integrates with Windows Update and WSUS, and can be customized with plugins and scripts. With CAU, you can keep your clusters secure and up to date with minimal manual effort. Use clusterware updating effectively. Ensure the failover clustering feature and tools are installed on all nodes. Configure remote management, enable necessary firewall rules, and verify that all nodes are in the same domain. Disable automatic updates on cluster nodes to avoid conflicts, and use a consistent update source. Test cluster updating readiness with the CAU Best Practices Analyzer before applying updates. Following these best practices ensures smooth, reliable updates and reduces the risk of downtime. CAU uses plugins to coordinate updates. The default plugins support Windows Update Agent and hotfixes from SMB file shares. You can specify plugin arguments, schedule updates, and use pre- and post-update PowerShell scripts for custom actions. CAU supports exporting update reports and integrates with existing IT processes. For advanced scenarios, you can develop custom plugins to meet unique requirements. This flexibility makes CAU a powerful tool for maintaining cluster health and compliance. Cluster Health Service provides real-time monitoring and reporting for storage spaces direct clusters. It collects essential metrics like CPU usage, I/O latency, throughput, and memory availability. Administrators can access these metrics using PowerShell or Net APIs, enabling proactive monitoring and troubleshooting. The health service also detects faults, such as failed disks or network issues, and provides actionable recommendations. By leveraging the health service, you can maintain optimal cluster performance and quickly address potential problems. Cluster faults are issues detected by the health service, such as failed disks, network problems, or insufficient capacity. Each fault includes severity, a description, recommended actions, and location information. The health service groups related faults to identify root causes, reducing noise and helping administrators focus on what matters most. Faults are automatically cleared when the underlying issue is resolved. Monitoring and responding to faults promptly is essential for maintaining cluster health and preventing downtime. Windows Error Reporting (WER) is a valuable tool for troubleshooting advanced cluster issues. WER collects logs and diagnostic data when failures occur, such as a physical disk failing to come online. Administrators can enable additional event channels, gather logs, and analyze reports to identify root causes. WER integrates with PowerShell for automated log collection and supports exporting reports for further analysis. By leveraging WER, you can efficiently diagnose and resolve complex cluster problems. BitLocker Drive encryption can be used to protect data on cluster shared volumes (CSV). BitLocker integrates with failover clustering, allowing volumes to be encrypted and unlocked automatically by the cluster. Protectors can be based on Active Directory accounts or stored in the cluster database. BitLocker ensures data remains secure, even if disks are lost or stolen. Proper configuration is essential, including enabling BitLocker on all nodes and managing recovery keys securely. This adds an extra layer of protection for sensitive data in your cluster. Cluster OS Rolling Upgrade allows you to upgrade your cluster nodes to a newer Windows Server version without downtime. The process involves draining workloads from one node, upgrading the OS, and rejoining the node to the cluster. This is repeated for each node. Once all nodes are upgraded, you update the cluster functional level to unlock new features. Rolling upgrades support Hyper-V and scale-out file server workloads, making it possible to keep services online throughout the upgrade process. Planning and testing are key to a successful upgrade. You can upgrade failover clusters to newer Windows Server versions without replacing hardware. This involves evicting nodes one at a time, upgrading the OS, and rejoining them to the cluster. The Copy Cluster Roles wizard helps migrate resources, and shared storage ensures data continuity. After all nodes are upgraded, update the cluster functional level. This approach minimizes costs and downtime, allowing organizations to stay current with the latest features and security updates. Cluster domain migration is the process of moving a failover cluster from one Active Directory domain to another. This may be necessary during mergers, reorganizations, or infrastructure changes. The process involves removing cluster name accounts from the old domain, changing node domain membership, and recreating accounts in the new domain. Windows Server 2019 and later support cross-domain migration with PowerShell CMDlets, simplifying the process. Proper planning and backups are essential to avoid data loss and ensure a smooth transition. Workgroup clusters are a special type of failover cluster that doesn't require Active Directory. Introduced in Windows Server 2016, workgroup clusters allow nodes to join as member servers in a workgroup, reducing costs and complexity. They support workloads like Hyper-V VMs and SQL Server availability groups. Workgroup clusters require identical user accounts on all nodes, proper DNS configuration, and supported storage technology. While they offer high availability without AD, they're not suitable for file server roles due to authentication limitations. Some environments, administrators may not have permission to create computer objects in Active Directory. Prestiging allows a domain admin to create the necessary cluster name object, CNO, and virtual computer objects, VCOs, in advance. This process involves creating and disabling the objects, assigning permissions, and ensuring the cluster can create additional resources as needed. Prestiging provides more control over naming conventions and security, and is essential in tightly controlled AD environments. Cluster accounts in Active Directory are crucial for cluster operations. The Create Cluster wizard automatically creates the cluster name object CNO and grants it permissions to create additional computer objects for clustered roles. If permissions are changed or objects are deleted, cluster operations may fail. Administrators must ensure the correct permissions are maintained and plan for password resets and account maintenance. Proper configuration of cluster accounts ensures seamless creation and management of clustered services and applications. Cluster affinity rules control how roles and virtual machines are distributed across nodes. Affinity keeps roles together while anti-affinity tries to keep them apart. Anti-affinity class names can be set to prevent resource-intensive VMs from running on the same node. For stricter separation, cluster-enforced anti-affinity can be enabled, which blocks roles from running together at all costs. These settings help optimize performance and resource utilization, especially in clusters with multiple workloads. VM load balancing automatically distributes virtual machines across cluster nodes to optimize resource utilization. It evaluates memory pressure and CPU usage, migrating VMs from overloaded nodes to underutilized ones. Load balancing can be configured to run periodically or only when new nodes are added. Aggressiveness settings determine how sensitive the system is to load imbalances. This feature ensures efficient use of hardware and maintains optimal performance for all VMs. Windows Server supports simplified SMB multichannel and multi-NIC cluster networks, enabling the use of multiple network adapters on the same subnet. SMB multichannel is automatically enabled, providing increased throughput and fault tolerance. Multiple NICs can be used for both cluster and client traffic, and administrators can configure network roles as needed. This setup maximizes network performance and ensures redundancy, critical for high-availability clusters. Cluster shared volumes, CSV, are essential for shared storage in failover clusters. CSVs allow multiple nodes to access the same LUN, supporting workloads like Hyper-V and Scale-Out File Server. CSVs are formatted with NTFS or RAIFS and support direct I/O for performance. In case of connectivity issues, I/O is redirected through the coordinator node. CSVs can be renamed, and the CSV cache can be enabled for read-intensive workload. Proper CSV configuration ensures high performance and seamless failover. Backing up CSVs is straightforward and can be done using Microsoft or third-party backup applications. Volume-level backups can be run from any node, and both software and hardware snapshots are supported. For clusters with multiple VMs, management OS-based backups are recommended. Always review your backup application's capabilities and limitations, and ensure you have a tested restore plan. Proper backups are essential for disaster recovery and data integrity. Storage Spaces Direct can be deployed in guest clusters, providing virtual shared storage across VMs in private or public clouds. Guest clusters require at least 2 nodes, proper witness configuration, and supported storage technologies. Anti-affinity rules should be used to distribute VMs across hosts. While guest clustering offers high availability for virtualized environments, certain features like host-level snapshots are not supported. Careful planning ensures resilient and performant guest clusters. Deploying a quorum witness is essential for cluster resiliency. Choose from cloud, disk, or file share witnesses based on your environment. For cloud witnesses, ensure Azure connectivity and proper storage account configuration. Disk witnesses require shared storage accessible by all nodes, while file share witnesses need an SMB share. Configure the witness using Failover Cluster Manager or PowerShell, and verify connectivity and permission. Properly configured witness ensures your cluster can survive node failures and maintain high availability. Cluster sets enable organizations to scale out by grouping multiple failover clusters into a single fabric. This approach increases resiliency, supports libmigration across clusters, and provides a unified storage namespace. Deploying cluster sets involves creating a management cluster, adding member clusters, and configuring infrastructure SOFS roles. Fault domains and availability sets can be defined for enhanced redundancy. Cluster sets are ideal for large, dynamic environments requiring maximum flexibility and uptime. Effective management and monitoring are key to cluster success. Use Failover Cluster Manager, Windows Admin Center, and PowerShell CMDlets for day-to-day operations. Monitor health, performance, and event logs regularly. Set up alerts for critical events and automate routine tasks where possible. Regularly review cluster validation and health reports and keep documentation up to date. Proactive management helps prevent issues and ensures your cluster continues to meet business needs. Troubleshooting is an inevitable part of cluster administration. Common issues include node failures, storage connectivity problems, and misconfigured permissions. Use built-in tools like Windows Error Reporting, Health Service, and Event Logs to diagnose problems. Validate cluster configuration regularly and review recent changes. For persistent issues, consult Microsoft documentation and community forums. Keeping your cluster updated and following best practices minimizes the risk of outages and simplifies troubleshooting. In summary, failover clustering is a robust solution for high availability and scalability in Windows Server and Azure local environments. By following best practices in planning, deployment, management, and troubleshooting, you can ensure your critical workloads remain online and resilient. Regularly validate your cluster, keep systems updated, and monitor health proactively. Whether you're running a small two-node cluster or a large-scale cluster set, these principles will help you achieve reliable, efficient, and secure operations. Thanks for watching, and be sure to check out additional resources for deeper learning.